Very well. Suppose you have a region like R, which is bounded by a graph like F, x-axis, x equals to A, and x equals to B. So you have two vertical lines. So you have a region here. Suppose your function f is positive. So this is your function f. Suppose you revolve this region R about y-axis. Okay, vertical axis, y-axis, and we are just revolving this region around y-axis. A solid is generated whose volume can be calculated using Shell's method. Okay, so what we're going to do, we're going to take a slice of this region. We're going to use a representative like x sub k star and the length, which by plugging xk star into the function, you can find this length. And suppose delta x is actually the thickness of this slice. So what are you doing? You're taking this slice and continue revolving this around y-axis. As you can see, it forms a cylinder. These small slices all together and so on. The circumference of the circle is equal to 2 pi xk star. This is the length. If you expand your cylinder, it has a length 2 pi x sub k star, and the height is equal to f of x sub k star. And finally, you multiply it by the thickness of this slide here. Very well. So these k's are changing. And as you take the Riemann sum of all of these cylinders and take the limit, send n to infinity, you can actually form the integral. The integral 2 pi x f of x d of x, while x ranges between a to b, actually gives you the volume. So let us officially define volume by the Shell method. Let f and g be continuous functions. F of x is greater than equals to g of x. Suppose it's the region between two functions on interval a to b. If R is the region bounded by the curves f of x and g of x between two lines x equals to a and x equals to b, the volume of the solid generated by R is revolved about y-axis, follows the following formula. First of all, we take the difference between f and g. Remember that if you don't know which function is upper function, which one is lower function, you can always use absolute value and you multiply the difference by 2 pi x, take the integral to find that volume. Let's go over one example to feel more comfortable about this method. Very well, suppose R is the region bounded by the graph f of x equals to sine x squared. Guys, this is not sine squared. It's different from sine squared of x. This is not this function. This function is saying that I have sine and I square my x. So R is the region bounded between this trig function, x-axis, and the vertical line, x equals to square root of pi over 2. So this is your sine function, x-axis, and here you have your vertical line, x equals to square root of pi divided by 2. It says find the volume of the solid generated when R is revolved about y-axis. Take a look at the graph. This is your region, and you're revolving this region about y-axis. Very well, we have a nice formula here. Our formula says, hey, the volume is equal to the integral of 2 pi x times f of x, d of x, while x ranges between a to b. So a, the lower limit, is 0, b, the upper limit is square root of pi over 2, and your function is sine x squared. You can use u sub method. Let u be x squared. So du is 2x dx. So here you have the integral of pi sine u du. This is equal to minus pi cosine x squared, x ranges between 0 and square root of pi over 2. So when you plug in square root of pi over 2, cosine of pi over 2 is going to be 0. When you plug in 0, the cosine is equal to 1. Since you have subtraction in between, the outcome is equal to pi. Another example for you. We're going to apply Shell's method when we revolve the region about x-axis. Perfect. Here we have a region like R in the first quadrant. Okay, let's just circle this guy to make sure that we know that we are in the first quadrant, bounded by the graph of y equals to square root of x minus 2, line y equals to 2, and question says find the volume of the solid generated when R is revolved about x-axis. Let's take a look at our region here. So our function y equals to square root of x minus 2, line, horizontal line, y equals to 2. And since we are bounded in the first quadrant, it means that we have these boundaries here as well. So this is our region. We are taking this region and we are revolving this around x-axis. Okay, our original formula says, hey, v is equal to integral a to b 2 pi x f of x dx. Now we are revolving this around x-axis. You know that x-axis is line y equal to 0. So your formula is now v equals to, for example, c to d 2 pi y gy dy. Very well. My function is y equals to square root of x minus 2. First, I have to write x in terms of y. Y is square root of x minus 2. So x minus 2 is equal to y squared, or x is 2 plus y squared. This is my g function. Gy is 2 plus y squared. I have 2 pi times y. Now I need to find c and d, the lower and upper bound. Take a look at your region. Your x ranges between 0 to 6. If you set y equals to square root of x minus 2 equal to y equals to 2, you can actually find your x, and when you write x minus 2 equals to y squared, x equals to y squared plus 2, you can find the rest of the boundaries. So if you set these two equal to each other, you get 2 equals to square root of x minus 2. X minus 2 is equal to 4, or x is equal to 6. This is the range for your x. But note that since we're using the second formula, we need the boundary for y values. The lower bound is of course 0 because we are in the first quadrant, and the upper bound is nothing but 2. Y is equal to square root of x minus 2, which is 2. So the volume is the integral 0 to 2 pi y, and your gy, which is y squared plus 2 dy. Now you distribute y into parentheses and take the integral. 2 pi stays outside the integral. Here you have 2 pi. The integral of y cubed is a fourth y to the fourth, and the integral of 2y is y squared. Y ranges between 0 to 2. Since you have variables in both terms, by plugging 0, you get 0. So just plug in 2. 2 raised to 4, 16. 16 divided by 4, 4 plus 4, 8. 8 times 2, 16. And 16 pi is the volume. Let us move on to the next example. Okay. So our region R is a region bounded by the curve y equals to square root of x, line y equals to 1, and y-axis. First of all, use shell method to find the volume of the solid generated when R is revolved about line x equals to -1/2. B. Use disk or washer method to find the volume of the solid generated when R is revolved about the line y equals to 1. Very well. So let us take a look at our region, then start revolving the region. This is curve y equals to square root of x. Then you have y equals to 1. If you set these two equal to each other, you see the intersection is at 1. So 1 and 1. And this is your region, bounded between these two. So we're revolving this about line x equals to negative a half. X equals to negative a half gives a shift to the left-hand side. Minus 1 over 2. So remember the formula. V is equal to the integral a to b 2 pi x f of x dx. Revolving around y-axis. When you have y-axis, it means that you're working with line x equal to 0. Now you are shifting this a half a unit to the left-hand side. So x is equal to 0. X is now equal to negative a half. By adding a half to both sides, you can make the shift to line x equal to 0. X plus a half is replaced in the formula. So again, this is your original formula to find the volume. Instead of rotating this, revolving this around y-axis or x equal to 0, you are now having a new line x equals to negative a half, which is on the left-hand side of your region. If you bring negative a half to the other side, you're actually making this shift, x plus a half. So instead of x, now you use x plus a half. V is equal to the integral 2 pi x plus a half f of x dx. What's the lower bound? What's the upper bound? Identify those and solve this integral. Our x ranges between 0 to 1. When you set these two equal to each other, x is equal to 1, the intersection between them. So x ranges between 0 to 1, 2 pi, x plus 1, x plus 1, and your function f is 1 minus square root of x. Y is 1, y is square root of x, so you're dealing with two functions, f of x minus g of x. Very well, let us distribute x into parentheses, then distribute a half into parentheses, and simplify as much as we can. X times 1, x times square root of x to 3 halves, a half times 1, a half, and a half times negative square root of x gives you negative a half square root of x. The integral of x is a half x squared. The integral of x to 3 halves gives you 5 over 2 x to 5 halves. So you can flip the fraction and you get 2 over 5 x to 5 over 2. And the integral of a half is a half times x. The integral of x to a half by adding 1. So let me write these down here for you. The integral of x 3 halves dx is 1 over 1 plus 3 halves x 1 plus 3 halves, which gives you 1 over 5 over 2 x raised to 5 over 2. which is 2 over 5 x2 5 over 2. This is coming from this integral. All of these terms have variable x, so forget about plugging 0. Just plug in 1, you get a half minus 2 over 5 plus a half minus a third multiplied by 2 pi, which gives you 8 pi over 15. Well, second part of the question, part B, use disk or washer method to find the volume of the solid generated when R is revolved about line y equals to 1. Y equals to 1. Okay. Disk, okay, y disk. Any other suggestion? We have one function, okay, not sure. Think, take a minute or two, think about this. Washer for 2 function, okay. What are those 2 functions? Think about it, guys. Shell method, okay. So we have disk method and we have shell method. Disk and shell. How do you set up your disk method? How do you set up your shell method? So you're saying that you have y minus y sub 0 minus y sub 1. So the top function is which one? So take a look at this, guys. We are taking this and we're just rotating this about y equals to 1. What do you suggest? One minus root x. Disk or shell? Guys, take a minute or two, think about this. We have one answer, disk integral 1 minus square root of x squared dx. This is one answer. The rest of the class. Integral from 0 to 1, 2 pi y plus 1 y squared dy. Okay, we have two answers here. The rest of the class, what do you think? For disk method, what's the lower limit? What's the upper limit? Zero to 1, 0 to 1. So take a minute or two, solve these two, give me your final answer. One over 6 for which one? Is this disk? Is this disk? Is this shell? For disk and Jade, both of you got 1 over 6. So you mean there is no difference between these two? Okay, just okay. Both of you got it for disk. So what's the reasoning behind it, Kyle? Guys, think about it. This is a good practice. Which method to use here? 7 pi over 6. Okay. So as you can see, these two are different. So my question is, which method? Okay, let me share my screen with you. So here we have these functions. And we're trying to rotate this around y equals to 1. So what are we doing? We're taking this function and we are rotating this, revolving this. What about now? Two pi over 3. Okay, you got pi. The correct answer is pi over 6. But why is that? You can say that, hey, I have the integral pi 1 minus square root of x raised to 2 dx. And your x ranges between 0 to 1. This is equal to the integral of pi 1 minus 2 square root of x plus x dx. So this is equal to x minus 2 divided by 1 plus a half, 3 halves, x2, 3 halves plus a half x squared. 0 to 1 times pi. So here you get 1 minus 4/3 plus a half times pi. Let us simplify this. So if you take the common denominator between these two, you get 3 halves here, you get pi. 3 halves minus 4/3, which gives you 9 minus 8 pi times 1 over 6 or pi over 6. Take your time, write this down. The question for part B said use disk or washer method. Okay, perfect. Any question here? Any confusion? Okay, perfect. Very well, let us get back to our canvas. Let us open